In this webcast, I wanted to take a few minutes to explore the Protein Data Bank website. For those of you whose molecules involve an interaction with a protein as part of their mechanisms, using the Protein Data Bank is going to be very important, and so getting the most out of it is very important as well. The first thing you're going to have to do with the Protein Data Bank is actually find your molecule. The way you can do that is by using the search box up here for a very basic PDB ID or text search. You can change the search, for instance, zeroing in on a particular chemical name or ID using the drop-down menu. And hopefully, after searching, you'll find something related to your molecule. But if you don't, you're not completely sunk. Using the Advanced Search button, you can provide some more search criteria or find molecules or proteins that are similar to those that you're covering for your Molmodac topic. So if you see literature that connects your molecule to a related ligand for a different protein, or for the same protein, or for a protein that's related to the one that your molecule binds to, then feel free to use the PDB to explore these analogous structures as well and incorporate those into your Molmodac page, being sure to note the analogy between what you're showing and the molecule you're actually covering. Once you've found a PDB entry that you're interested in, clicking on it will bring you to this page. There's a lot going on this page, but there are a few key areas that you should zero in on in order to get the most information you possibly can out of each PDB entry you look into. So the first place you should look is here on the right, where you see this View in Jmol link. Clicking that will bring you to a page where you can manipulate the Jmol of the protein. You can apply commands to it using the box down here, and rotate it, translate it, and zoom using the usual mouse commands. You can save a state file containing any manipulations you make to this structure by right-clicking and going to Save Script with State. The state file that you save in this way can be directly uploaded to the wiki and used in a Jmol tag. There's no need to first save a structural file from the PDB and then upload that and a new state file to the wiki. You can use the PDB for more than just viewing Jmols. In fact, there are two tools that the PDB offers that I think can provide profound insight into proteins that you might come across. The first of these is the Protein Workshop, and you can access the Protein Workshop by clicking the link shown here and then clicking Launch Protein Workshop. This should automatically open the structure you're looking for. Upon opening, you'll see a black background with your protein like this. The primary sequence is rainbow colored, meaning that residues that are close in sequence are similar in color. So these structures give you an interesting idea of the relationship between primary structure and topology, or the lack thereof. You can turn on selected chains or amino acid residues by using the tree view you see here. The second of these tools is the Ligand Explorer. You can access the Ligand Explorer by scrolling down to the list of ligands present in the protein. We'll notice here that for each ligand, there's a button labeled Ligand Explorer, and clicking that button will open up an instance of the Ligand Explorer for that particular ligand. So clicking on this would bring us to a page where we could launch the Ligand Explorer, and upon doing that, we would see something like this. Here we see the ligand buried in the protein, but now the protein's residues are represented simply as straight lines to sort of cut out unnecessary spatial clogging around the ligand. It's very easy using the Ligand Explorer to see the key interactions that are involved in binding a ligand. You'll notice in the bottom left-hand corner we have a list of the various kinds of interactions that can take place, and by simply checking the box, the Ligand Explorer will automatically calculate the existence of these interactions. So by checking hydrogen bonds, for instance, we see a hydrogen bond between a lysine backbone nitrogen and the carbonyl of the ligand. We see yet another between a backbone carbonyl and an NH bond in the ligand. We can do this for any of the interactions, and as we check the boxes, the various kinds of interactions will get added to the display. The effects are cumulative, so to see all of the interactions present, we could simply check all of the boxes.